Well, enough theory. Let's now start learning how to do it. Well, first we need to do certain groundwork. We need to understand what is the business objective. So we need to understand the business. What are the key variables that would, let's say we are modeling for a sales, sales of retail store. We have to think then on what variables these sales, you know, depends. In the example, we will tell you a pricing concept. Alright, we first analyze the possible driving forces, that is x variables, on which my y variable depends, and also I need to see the hypothesis. What is the hypothesis? We first hypothesize then, what would be the relationship. Let's say price and variable, they are negative, they should be negatively correlated. So we need to make these lists. Then we should collect the data and also do a classification of data. And then we need to follow this procedure. We first need to do the groundwork as we have explained in the previous slide. We will do trend and correlation analysis. We will transform the variables whenever required. We will do centering and scaling. We will explain each and every step. We will divide the data into validation and training. We will check the multi-collinearity. We will do the variable significance check finally, and we will do iteration on the model, and finally we will arrive on the final best fit model. Well, there are certain assumptions that should be satisfied in regression modeling at various stages. So I'll just skip this and would come directly to classification of variables. So let's say I have these many variables. What I do, I classify them into different types. Let's say these are my pricing variables, these are my promotion variables, and these are my economy variables, macroeconomic variables. What I do, I put them in their respective buckets. So why should I do this? Because while making a model, we should always maintain traces of each bucket so that we can explain the model better. We can say that yes, pricing has this much contribution in the model, economic variables has got this much contribution in the model, and my promotion variables has got this much contribution in the model. Next step is transformation. Now what we do, while there is an assumption, there is a primary assumption that we will discuss. There is an assumption of linearity, that y and x should be linearly related. So while they are not, we try to make it. So like first we do like we did in the theory part, we first draw a xy scatter and check whether they are linearly related or not. So if my assumption is met, then we go forward. However, if my y and x scatter is something like this, and my line is this one, blue line, then there is no assumption of linearity. I'm sorry, assumption of linearity is not met. Then what we do, we transform the x variable to either root x or log x, and then we again check. Now if it goes like this, we go ahead. Similarly, in such cases we do following transformation. Alright, these are the four assumptions that we were talking. First assumption, now we are aware of assumption of linearity. Three more assumptions are there which we would discuss during modeling exercise. Second is independence of error, normality of error, and homoscedasticity. There is a weightage criteria that we can give to each observation. Well, like if we have year data from 2008 to year 2011 and we want to give maximum weightage to 2011, so we can give different weightages. We can decide on the weight scale and we can weight our observation. Well, it depends on the business acumen, whether you want to do it or whether you don't want to do it. There is also a concept of centering. Well, we will understand this. See, y equal to mx plus c. This we drive in our regression model. As I said, c is the value of y at x equal to 0, right? What if x can't be 0? This is not a possibility, right? It's not a possibility that x can be 0. Then somehow I am trying to make my line pass through a non-possible zone, right? So what happens sometimes that my intercept starts coming negative, and it is very hard to interpret why is it negative, and it doesn't make any sense. So what we do, we rather modeling on x, we model on x minus x bar. What is x bar? Is the mean of x. So we just difference the we just center the line of x. We just deduct x bar from x and make it shift to origin. Now the line hovers around 0. Now what we do, while model, my equation is y equal to m x minus x bar plus c. Now what is value of c? Well, value of c would be y at x equal to x bar. Isn't it more realistic? Well, x can't be 0, but definitely x can be x bar. So this c is more realistic, right? So sometimes during modeling exercise, it's preferable to do centering of the variable. So we now know centering and scaling. Now let's start. Alright, we will understand this also. Suppose we have data starting from 2007 to 2012. Well, it's a time series data, but in regression we need not to have time series data. Well, in this case, what I am doing, we have taken this much data for observation window for making model, and this much data we will check our model, how good our model is fitting in this window, right? We can also do some 80-20 breaking and 70-30 breaking based on the data size. If we have small data, we should go with this. If we have large data, we can go with this, or even 60-40, right? Depends. So model is trained on my test part, right? This part or this part, and then test it on validation window. Very important part of the model. Now let's finally regress. So I'll just open a case study for you and then we'll understand this.